Today we're going to be continuing our look at continuous random variables in the Gresty Academy podcast, a crash course in continuous random variables, looking at median and mode questions. And the question we're going to be focusing on is this one here. Let's just quickly go through it and then we'll explain what's going on. So we have a continuous random variable x here with probability density function f of x equals k over x cubed for x greater than or equal to 1 and 0. Otherwise, we need to find the mean, the mode and the median, and we also need to find the probability that x is between 2 and 4. Okay, so what we will need to do before we do A and B, clearly, is we will need to find k. But let's just go through all of this a little bit in general terms. So let's draw a nice little pretty graph here of f and f of x, where f of x is our probability density function. Okay, and let's just say, for example, that our probability density function is something like that. Okay, now the first thing that we've already learnt is that the area underneath the curve of the probability density function, the area equals 1. That's the sum of all of the probabilities. And we also dealt with this in a previous video, that basically is the integral between infinity and minus infinity of fx dx equals 1, which is the same thing as saying the area is 1. Now the mode is basically, what you need to do is you need to find the highest point of fx, and the mode is, so let's just write this, the mode is the value of x which maximizes f of x. So basically the maximum value of f of x clearly here is that. The mode is this point here. So that is the mode, and there are varying different ways of calculating that depending on what the shape of the probability density function is. That's the mode. Okay, the median is the value of x such that, let's just give it a bit more space here, the integral between minus infinity and m of fx dx equals a half. And what that means is, basically what they're saying is, we need to find the point at which the area of this half on the left, well, I haven't drawn that very well actually, it's probably going to be nearer to here, the area of this half on the left is exactly the same as the area on the right, and the point x, where if we split the left area and the right area, they're both half, because obviously remember the total area has got to be equal to 1 by definition of the probability density function. That is the median. Okay, and then finally we have the, as a recap, the mean. This is a recap, we've already done this, mu, which is the expected value of x, is basically equal to the integral between minus infinity and infinity of x times f of x dx, and we've already done that in previous videos. Oh yeah, one other thing, yeah, let's have a look. So basically the probability that x is between a and b, okay, well, let's just change colour here because it's getting a tiny bit confusing. Let's imagine that this point here is A and this point here is B. Well, basically the probability that x is between A and B is just going to be the area here. So basically that's how we're going to work out what the probability between any 2 points A and B are. And remember, it's clearly going to be less than 1 because the area of the whole thing is 1, because that's the definition of a probability density function. Okay, so let's go back into the question now. Let's get a little bit more space and let's actually do the question. Now, the first thing that we got to do is we have to find what k is. And the way we have to do that is we have to say that the integral between minus infinity and infinity of f of x dx, probability density function, must equal 1. They ask this so many times. It has to equal 1. Okay, so basically, therefore, we have the integral between infinity and 1, because it's defined for x greater than or equal 1. It's not defined for x less than 1, so we don't need to worry about x less than 1, of k over x cubed dx, which equals, because we can't really use infinity here, we have to use the limit as b approaches infinity of between 1 and b of k over x cubed dx. and that equals the limit as b approaches infinity of minus k over 2x squared between b and 1, which is the limit as b approaches infinity of minus k over 2b squared add k over 2, and clearly as b approaches infinity, this term here approaches 0, and so that equals k over 2. So basically this integral here equals k over 2, and we know it's equal to 1, so that equals 1, and therefore we have that k equals 2, and therefore we now know that our probability density function is f of x is 2 over x cubed for x greater than or equal to 1 and 0 otherwise. Okay, so that's the first thing. The second thing now is we can go on and find the mean, the mode, and the median. So let's give ourselves a bit of space here. So the mean, which is mu, which is also the expected value of x, is equal to the integral between minus infinity and infinity of x times f of x dx, which is equal to the integral between 1 and infinity of x times 2 over x cubed, because we've now established that k is equal to 2, which equals, again, because there's infinity here, we should really, strictly speaking, go the limit as b approaches infinity of the integral between 1 and b of 2 over x squared dx, which is equal to the limit as b approaches infinity of minus 2 over x between b and 1, which is the limit as b approaches infinity of minus 2 over b add 2 over 1, and clearly as b approaches infinity, this term here approaches 0, and so that equals 2, and therefore the mean, or mu of expected value of x, which is the mean, equals 2. So we've answered the first one. Okay, now the mode, which is the second thing we've got to find. Remember, that's basically, we have to find the highest point of fx. Well, as f of x is 2 over x cubed greater than or equal 1, we can actually draw it like this. Basically, here is the point 1, and when x equals 1, here is the point 2. So basically, we can draw this as something along the lines of that going all the way off to infinity. That is 2 over x cubed there, and so clearly the highest point on this is here, where f of x being 2, and remember, therefore, the mode, we have to drop it down, and so therefore the mode, by inspection, the mode is 1. Okay, so that's the second one. Finally, we can do the median. So the median, remember, is equal to the sum, the integral between minus infinity and m of f of x dx equals a half, i.e. half of the area is to the left of the median and half of the area is to the right, and we need to find m. There's only one unknown here, so what we do is we integrate. So basically the integral between m and 1 this time, because we're only interested in the point 1 to the right, because again it's 0, anything less than or equal to 1. So the integral between 1 and m of 2 over x cubed dx is equal to a half, which is equal to minus 1 over x squared between m and 1, which equals minus 1 over m squared add 1, and so therefore we have a half equals minus 1 over m squared add 1, i.e. 1 over m squared equals a half, so m squared equals 2, so m equals plus or minus root 2. Okay, now that has given us two answers, but clearly we can discard m equals minus root 2, because here is our function, here is our probability density function here. M equals minus root 2 is over here, and basically we know that the probability density function is 0 over here because it tells us in the question, and so therefore we know that root 2 must be the median. Okay, so we got the median here. So the median is root 2. Okay, so now actually, just out of interest, we could, if we wanted to, we can just redraw our graph here. So we have the point here, it goes down like that, something like that. So here is the point 1 here. So we have that the mode of our function, this is 2 over x cubed. We have 1 is the mode. The median was at root 2. The median was there. and the mean was at 2. So in actual fact, all three of the major statistical units of centrality or whatever are different. Now, the final part of the question asked us for the probability that x is between 2 and 4. Okay, well, basically what they're saying here is they want the area here between 2 and 4. Now, we know it must be less than a half, because we know that the median is root 2, and so therefore we know that it's going to be less than it's going to be less than a half anyway. So let's just have a look what it is. So it's going to be the integral between 2 and 4 of 2 over x cubed dx, which equals minus 1 over x squared, between 4 and 2, which equals minus a 16th, add a quarter, which equals 3/16. And so therefore we know that the probability that the continuous random variable is going to land between 2 and 4 is equal to 3/16. Okay, these are very, very common questions that they ask you here. Basically, the mean, the mode, the median, and especially this, basically the probability that the continuous random variable lies between two values. All you've got to do is just be careful and make sure you do your integration properly. Otherwise, these are relatively easy marks to pick up. Okay, well, I hope you've enjoyed this part of the podcast crash course into continuous random variables. If you have, please like the video and subscribe to the Gresty Academy YouTube channel. Look out for more podcasts on random variables as well. Thank you.